Good morning all. Today we'll be discussing about hydrograph. As we know, one of the method to estimate the runoff it is unit hydrograph method. Before going to unit hydrograph, let us understand what is a hydrograph. Consider a river basin. We have to measure what is the total runoff in that area. So, as we know, the runoff from the entire basin finally reaches to a stream or river. So, by measuring the discharge of the stream or river, we can understand what is the amount of runoff. So, the hydrograph is a graphical plot of discharge of a natural stream or river versus time. That is, discharge is expressed in cumex, that is meter cube per second, or hectare per day on y-axis, and time in hours or days or months on x-axis. The following figures represent the shape of hydrograph. First one represents the hydrograph of a single storm. For a multiple storm also this shape is possible. For that, consider a first storm occurs and its a direct runoff ceases, then the second storm occurs. Then the single peak hydrograph is possible, and that type of storm it is called isolated storm. And next one, it is a multiple peak hydrograph. In that case, first consider a rainfall occurs and its runoff, before its runoff ceases, the second storm occurs. Then in that type of rainfall, in that type of runoff, this type of hydrograph occurs, that is the multiple peak hydrograph occurs. And and that type of storm it is called complex storm. And normally a single peak hydrograph resulting from an isolated storms are preferred for hydrograph analysis. Next, we will discuss much more about the hydrograph. Consider a rainfall just begins. So, at the beginning, there is only base flow that contribute to stream. That is, there is a ground water flow is there already that contributes water to the stream. Okay, once the rainfall begins, what will happen? First, there will be some losses like interception and infiltration. Once these losses are met, the surface flow begins, and this surface flow finally reaches to the stream. Okay, so when it reaches the stream, what will happen? There is an increase in discharge in the stream. So first, this represents the base flow, and when the surface flow reaches the river, there is an increase in discharge in the stream, and it progressively increases to a peak value. As the rainfall ceases, what will happen? The runoff also reduces, so the hydrograph recedes, so there is a recession like this, and finally it reaches to a normal value. This represents the hydrograph of the river basin, and this is the hydrograph, that is we are measuring the. As I said earlier, at the beginning there is only base flow. That is, a groundwater contributes to the stream, that is it is indicated at point A. Okay, after the commencement of rain, when the initial losses like interception and infiltrations are met, the surface flow begins and the progressively the increase in the stream flow. The hydrograph therefore gradually rises and reaches a peak value, and at the time at time Tp, this time it is called time lag or base lag or time to peak. That is, it is measured from the centroid of effective rainfall of hydrograph. That means, consider now the intensity, now the rainfall is at maximum intensity, but at the same time the discharge in the river is not maximum, because the runoff developed from the rainfall from the entire catchment have to reach the river to increase the discharge. So there is a time lag. That time lag we are measuring with respect to the centroid of the effective rainfall hydrograph. That is, this represents the hydrograph, and this effective rainfall that represents the excess rainfall, that is a runoff. Okay. Then once the rainfall ceases, the runoff also decreases, and hence the discharge in the stream recedes. So we'll get a declining portion like this. As you can see, there is a point that is called inflection point. It is assumed to mark at the time at which the surface flow to the channel system ceases. That is, when the surface flow to the channel system ceases, corresponding to that time, we are marking the inflection point. That means there won't be any surface flow after that time. There will be only the subsurface flow and groundwater flow. Next one, it is hydrograph separation. What is hydrograph separation? That is, we are removing the base flow, or we are separating the base flow from the total runoff. The total runoff includes base flow, surface flow and subsurface flow. The surface flow plus subsurface flow, it is called direct runoff. That is, we are separating the base flow from the total flow in order to get the direct runoff. For that one, we are drawing a tangential line AC to both the lower limbs. Okay, both the limbs we are drawing a tangential line, and the area below this tangential line represent the base flow. Then method 2 for separating the base flow. In this one, first we are fixing the end point of the direct runoff, that is using an empirical formula, that is n is equal to 0.827 a raised to 0.2, where n represent the number of days after the peak. Okay, number of days after the peak, we are taking this point as the end of the direct runoff. If the large data, that is the discharge data of a river is available, then some other method to locate the direct end of the direct runoff. But if the data is, but normally that data won't be available, so we can use this empirical formula to locate the end of direct runoff. Then next step, in order to separate the area, first you have to drop a line, vertical line from the peak. Then you have to extend this recession limb before the rise, and this point is represented as D. From this point, join a line DE. Okay, that is the area under the line ADE represent the base flow. This shaded area represent the base flow. So this much area give the direct runoff. In the method 3, the first step is we have to locate the point E, that is already explained in the method 2. Then join simply the points A and E. The area under this line represent the base flow. So this much area represent the base flow. Next, we will discuss a negative base flow. That is, when the water level in the stream is low before the occurrence of flood, there is a flow of water from groundwater to a stream. But when the water level in the stream rises due to flood, there is a flow in the opposite direction, that is from stream to the groundwater. Okay. Such flow, it is called negative base flow, and this dotted line represent the variation in the base flow, and the shaded area represent the negative base flow.